Differential equations are the more common formulas we use in everyday computations. Instead of using the numerical methods, there are methods of approximation in complex equations. Learn more here in numerical solutions to CE problems. But what do we remember by differential equation? These are those types of equations which include derivatives in them. How do these derivatives occur in life? Recall that derivatives are changes, say with Newton's second law of motion stating that force is equal to mass times acceleration. We had learned in physics that acceleration is the change of velocity over time. There's the word change, which means derivative. Also, we say that acceleration is the second derivative of the displacement all over time. So we can form differential equations like F is equal to m times dv all over dt, where the force F is a function of the parameters velocity and time. On the other hand, we can say force is equal to the mass m times the second derivative of displacement all over time, where the force F is a function of displacement, time, and ds all over dt. Is differential equation that important? Take a look at algebraic equations. Such equations would always give fixed values while the world is constantly moving. For example, the slope of a tangent line in a curve would keep on changing in every small movement of a point. Differential equations, on the other hand, can determine changing values, and they are used in different phenomena like identifying speed, temperature, power, pressure, and a long list of other topics. There are two kinds of differential equations, where one is called ordinary differential equation, which is denoted as ODE. This is a type whereby it contains only ordinary derivatives. For example, are those formulas shown. Take note that there are different ways of denoting a derivative. As earlier used, dx all over dt is one way of showing a derivative, and the other is by placing a prime, which would also show a derivative. In the second example, we read the equation as the fourth derivative of y plus 20 times the third derivative of y less 5 times the second derivative of y plus y prime is equal to sine of 5x. The other kind of differential equation is what is called partial differential equation, or PDE. As its name connotes, this equation includes partial derivatives. We use a different symbol for partial derivative, which is a swirly d symbol called del. Reading the first example, alpha squared times the second partial derivative of y all over the partial derivative of x squared is equal to the partial derivative of y all over the partial derivative of t. While the second example is another way of writing the second partial derivative, which is read as a squared times the second partial derivative of u, both with respect to x, is equal to the second partial derivative of u with respect to x and y. What we are going to focus on with approximation is the initial value problem. This is the task of determining the function of y of x when the derivative x0 and y0 are provided. As you have already learned, the numerical solutions to IVP in differential equations would be in approximating values. In this series of videos, we will discuss Euler's explicit method, modified Euler's method, Runge-Kuta's method, which would include second order, third order, and fourth order. And lastly, modified Euler's predictor-corrector method.